everyone, welcome back to the LeetCode 55 jump game problem. So let's understand the question first. So what it tells that you are given an integer array nums. You are initially positioned at the array's first index. That means here they are telling that we are provided an array. So let's say the array to us is 2, 3, 1, 1 and 4. And here what they told that you were initially positioned at the array's first index. That means we are initially at the first this zeroth index. First this zeroth index. And each element in the array represent the maximum jump. Each element in the array represent your maximum jump length at that position. That means it represent जितना maximum jump कर सकते हैं. That means each element in the array, that means those all elements represent the maximum jump. That means the amount we can jump from here. Return true if you can reach the last index or false otherwise. So it tells that if suppose this is 2, so we can either move 2 step or we can move 1 step. So this is the maximum jump amount that we can. So this is, so what that tells that if we can reach up to this index. So let's say the whole length is n. So what will be the index of this? The index of it will be nums.length minus 1 in terms of array, in terms of this array. So that will be the maximum length of this index. So it tells that we have to reach, if we reach the last index, that means if we reach this index, that index, then we will be simply returning true. So first we have to think that how we can solve this problem. So to solve that type of problem, we can, it's a type of dynamic programming problem. So first try to understand what we have to do. That first here is 2. So we can think like this. That means we can reach up to a distance of 2. This is the distance of 2. Either we can reach up to a distance of 1. Okay. Now suppose we reached up to this 3. Now either we can move up to a distance of 1. We can move up to a distance of 2, 1, 2, and we can maximum move up to a distance of 3. Now notice the important things to look here is each time we have 3. So this is our current index, that is our current index. But with the help of this current index, either we can move up to this position, up to this position, or up to the greatest position. So we can call it that it is the maximum reach position. That means we will be utilizing a variable integer max reach. We'll be initializing by 0 just to track the maximum power. The maximum power we can move from anywhere. So this is integer maximum reach. Now at every step, suppose if we just check the second example, 3, 2, 1, 0, 4, and if we just notice this example, so suppose first this is 3. So how we can traverse from here? We'll be traversing like this. Either we can traverse from here to here, either from here to here, and from here to here. So let's say we traverse the maximum one, that is maximum reach distance. Here is this. So here the maximum reach distance here becomes the index up to this position. So 0, 1, 2, 3. So this is maximum reach equals to 3. Okay, that is the distance. But when we use the loop, because we have to traverse for all the elements, here, here, here. So we'll be utilizing a loop. So when, if we suppose come here in that position, so i's value will be equals to 3, and here the value of I will one time exceed this one, that will exceed this one, and that time we cannot update this value because there is 0. And when I will be coming here, we cannot update the maximum reach, because from here if we I plus 0, so the maximum reach will still remain at the 3, and I will come at the position of 4. Here after this step I will be 4, but the maximum reach distance will be the same as fixed. So this is one of the conditions that if that type of condition is made to us, that means if I greater than maximum reach, then simply we'll be returning false. then we'll be returning false. Then how we can update the maximum reach? Every time we update the maximum reach from this position. So if you notice this position here, this is 1 and the maximum distance it reaches is 1, 2, 3, 4. That means if this is having a power, it reaches up to 4. That means if the index is 1, and the value is 3, and the value is 3, then only it reaches 4. So that means it is index plus nums of index, the value of the index. So this is how we can update the maximum reach. So we'll be updating like this: maximum reach equals to maximum reach. Now we are updating the maximum reach, math.max, and then the previous maximum reach will be using here previous maximum reach, and then the I plus nums of I, that is index plus value of that current index. Now we'll be checking the last condition that we have to notice, that if the value, if this value, the value of this one, that is maximum reach value, if this maximum reach is sometime coming at that position and that position, that is if our maximum reach is exceeding, let's say we took from here to here and then we are taking from 3 to this index, so we can see we are reaching directly up to this index. So if that is equals to or greater than equals to, that means if this is exceeding this one or up to this one, that means we are reaching the meet criteria where we have to return the true as answer. So we'll be simply writing if maximum reach distance is greater than the last index. The last index is nums dot length minus 1. So it's greater than nums dot length minus 1, the last index. Then we'll be simply returning true. Then return true. Okay, so we return true, and then if after all those operations are executed, if we didn't got the true answer, that means simply false, we cannot reach up to this index, return false. So this is simply return false. So first let's execute this program on the code, and then we'll have a recap of this, that how we can solve this one. So let's move to the coding section. Okay, so now we'll be coding. So first what we have to do, that we need a variable to declare the maximum reach, that is integer maximum reach. So let's declare integer. Look, this is first we have created here. Okay, so now we'll be solving the jump game. So as we know, first we require a maximum reach. So let's declare integer. Okay, now we declare the maximum reach. Now what we have to do, that we need to traverse this entire array, and then we have to apply the condition. So for integer I equals to 0, I less than, and now first, if in this condition, when we'll be reaching this position, look, you will always arrive at index 3. That means we'll be arriving at this index, and once we arrive that index, we cannot update in the next position. That means one time our loop will come in at this position for index I equals to 4, but our maximum will be this. That means if our index exceeds, if I is greater than maximum reach, so we cannot reach up to the end, then we'll be returning just false. Return false, as I made you understand. Okay, now we'll be updating our maximum reach. So let's maximum reach, math.max. So the current maximum reach will be comparing whatever the maximum, will be updating that one. Maximum reach and the current position plus numbers of I, and then we'll be checking if maximum reach is greater than or equal to the last index, that is nums dot length minus 1. Then we'll be returning true, return true. And if these conditions, after executing all those, we didn't got true answer, so simply we'll begin returning false, return false. That means solution doesn't exist. And let's compile. Yeah, it got compiled, and now we are submitting. So okay, in next we'll be meeting in next video session.